Okay. The quadratic function look like that. Ax squared plus bx plus c, no? This is the standard. And we have another form that's called vertex. But no. In this case, no vertex. Now, this quadratic function is a parabola. Maybe open up or open down. That depending of the sign of A. So A control. See, A is positive. Open up. See, A is negative, open down. Okay. And now also I focus on the most important point. Look, the most important point is the vertex, is this point. When the parabola open up, this is the minimum. And when the parabola open down, this is the maximum. And we using this, we take advantage this fact to optimize. Optimize means you try to find the best solution in the problem. Okay, the first application problem is suppose that the manufacturer of the gas clothes dryer, okay, something, has found that when the unit price is $P, I suppose that P is like our independent variable X in the equation, P. The revenue, R, capital R, in dollar is expressed by this formula. This formula is given always, you know. And you recognize that this look like the quadratic function because the exponent 2 declares perfectly que es quadratic. Degree 2. Therefore, I can see, compare our specific formula and the standard, que A is -4, B is 4,000, and C is missing, is 0. Okay? Therefore, I know that this parabola open down because A is negative. And this point is the famous point in which maximize the profit. The profit, no, the revenue. Sorry. So they want to know what unit price should be established for the dry something to maximize the revenue. So in other words, I need to find the vertex, que is the maximum in this case because A is negative and the parabola open down. And finally, compute the maximum revenue. Okay. What is the most important formula? The most important formula is this formula. Minus B over 2A. Because this gives me the H value of the parabola. Remember the vertex, the famous point H, K. Pero H represent the X component, K represent the Y component of the vertex. In our problem, X is P, because this is the independent variable. And Y, que es K, represent the revenue. Okay, que is connecting by this quadratic function. Okay. Entonces minus, remember the formula contains minus, B is 4,000 divided by 2 times, A is -4. Be careful with the signs, because we have double minus, no? Double minus become positive. Actually is 4,000 divided by 8, because 2 times 4 is 8, is 500. 500 something. 500 is the unitary price, P. And this 500, I suppose, que es dollar. So in this case, it's a coincidence que the X is dollar, and revenue, of course, is dollar, no? But not always happen, no. In this problem, yes. So I need to establish the unitary price like $500, no? If you want to obtain the maximum revenue. Okay, perfect. And what is the maximum revenue? Well, it's the maximum revenue you can find plugging in 500 into the revenue. So you can put revenue under the supposition que I established $500 like a unitary price, ¿no? Entonces, -4, 500 square plus 4,000 multiplication by 500. Well, the rest is calculated. And the answer is 1 million. 1 million. $1 million. End the story, guys. Any question? It's easy, it's clear. I promise que in the test number 3, no? We can find 2 problems similar to this. I bring 2. Now, this is the first one. Do you understand or no? Clear. Oh, super. Very well. Sabrina says it's clear, Professor. Okay. Everyone is agree que it's clear? Okay. Clear. Okay. Let's move on to the second problem I bring today. I bring today another problem. Is the second problem. Okay. This is the second problem. The second problem is a little bit different because it's the marginal cost in dollar, capital C, of the manufacturer X cell phone in thousand is given by this. And this again is the quadratic function. Okay. By the way, expressed in standard, so I realize that AFI, B is -200 and C is 4,000. This is also in dollar, the cost, but X is not in dollar. X is cell phone. So basically, you need one cell phone, X represent. Okay, so again, we have a parabola. In this case, the parabola open up. How do you know? Because A is positive. So we have here A minimum. It's exactly the same day one. Day one, you find the minimum cost. Okay, so how many cell phones should be manufactured to minimize the cost? Okay, in other words, I need to find in the vertex point H, K, okay, the X component represent the cell phone and the K component represent the cost. This is the cell phone and this is the cost. This is in unit, no? And the cost is in dollar. Okay, so again, we're using the famous formula. The optimization when it's quadratic function, we're using always that formula. Okay, so now the formula contains the minus. Don't forget the minus of my formula. B is 200, 2 times A, que is 5. Okay, so this is, wait, I forgot que B is negative. Entonces we have double minus, right? Minus. Double minus become positive. Entonces es positive 200. Positive 200. Divided by 10, ¿no? Que es 20. 20 units. 20 units. 20 is cell phone. In order to find the cost, you plug in the cost function 20 minus 5, no, positive 5, 20 square minus 200, 20 plus 4,000. Let me try to use my calculator because I don't know how to compute that. Okay, the function is 5x squared minus 200. I'm typing in my calculator now. X plus 400. 400 no, 4,000. So that X is equal 20. I press enter. The answer is 2,000. 2,000 what? $2,000. It's the minimum cost that you expect. Any question, guys? Entonces, this is one. So, two questions in the test number 3 is optimization word problem, no, using quadratic function. Okay. According to the syllabus, I suppose that everyone understands very well, no? It's easy, super easy. Today we start new topic, important, extremely important and hard, complicated. It's about rational. We don't have, no. If you want, yes, Sabrina. If you want, but no. We start first rational functions. Okay, rational functions. Okay, rational function. Okay. Now, number one definition. Definition is rational function is a function que is created by the division two polynomials. So you have p of x divided by q of x. And what about p and q? P of x and q of x both are polynomial function. The only restriction is que q never is zero. Okay, it's an arbitrary polynomial, pero no zero. That's the only restriction because you know that when you divide by zero, it's undefined. Okay, let's see example of the rational function, and we determine two things. Number one, domain. Number two, factory form. So we have, let me create one chart like that in which the first column is the functions. Okay. The second column is the domain. And the third column is the factory form. Okay. Let me start for the first example. It's just the function f of x equal 1 over x. Well, actually, in the top, we have 1, okay, 1 is a number, okay, we can consider like a polynomial degree 0, okay? And x alone is a polynomial also, but degree 1, because the exponent, no, is 1, invisible 1. Remember, the degree of the polynomial is the higher exponent. So you have collection of the monomial, you take the monomial that contain the higher degree, the higher exponent, sorry, and this is called a degree of the polynomial. Entonces es obvio que in this case the domain is all real numbers such that x not 0. Because is x is 0, division by 0 is undefined. Remember, guys, 1 over 0, the answer is undefined. Undefined means equivalent to say to not exist. Okay? We cannot find any number when you divide by 0. No, it's not necessarily 1. Any number divided by 0 is undefined. And the factor form one stays the same. The factor form stays the same. Doesn't change. Because in the top we have 1 over x. We cannot factorize. This is a straightforward example. Very, very easy example. Everyone follow me? Sure? Number 2. Number two is a function g, rational function. We discussing now example of the rational function. In the top, we have monomial expression, degree 2. And the bottom, we have trinomial, degree 2 again. Okay. What about domain? Well, let's do it in a different way. Number one step always in this problem that we discussed from today, and we continue next time because it's too long. You express a g in factory form. Well, on the top, there are nothing to do. Stay the same because of monomial. But in bottom, no. We can factorization that trinomial. And the factorization of this trinomial, I know it's 2 binomial. And the combination is 3 and 2. Because 3 times 2 is 6. And somehow 3 plus 2 is 5. And both negative, right? Okay, this is the factory 4. Que is equivalent, no? Algebraically to the original is given. But you see now a little bit more clear que the fact to be undefined, our function is the factor. So you take the expression, the denominator que es x minus 3 equal to 0 and x minus 2 equal to 0 because it's totally illegal division by 0. Therefore, x is 3 and x is 2. And they are the bad guy. Because the domain is all real numbers such that x no 2, comma, x no 3. Okay? This is the 2 restriction that we have in our problem. Okay? It's similar to the problem we are doing in the test 2, no? When you have restriction, in this case division, in this case no square root. So the function that we study now, rational, no include a radical, because include radical is irrational. In this case, polynomial divided by polynomial. It's nice. Well, no too much, but it's nice. Okay, number 3. Number 3 is called h of x is equal, suppose x plus 3 in the top, divided by x squared plus 4 in the bottom. Okay, the degree of the polynomial in the top is 1, degree 1, degree 1. How do you know that 1? Because the exponent here is 1, no? And the degree of this is 2. It's important that you be aware for the degree because we are using, not now, we are using after. I promise. The idea to the degree of the polynomial. Okay? Okay. So now it's easy because in the factory 4, wow, in the factory 4, look at what happened. The top part stays the same because you cannot do anything, right? However, in the bottom part, look at that. See, you have x squared minus 4. Everyone understands that the factorization is xx to 2, like a classical differences of the square. But si es x squared plus 4 is prime expression. We cannot factorization this. Why no? Why no? Well, the reason is clear. Because suppose que I have no idea, or I don't remember that the sum of the square is impossible to do the factorization. Well, okay, I try to investigate the domain. I take the polynomial in the bottom, I enforce it to be 0, and I solve this equation. Or I try to solve this equation. So now, x squared, I move 4 to the other side, it's negative 4. And when you apply square root, wow, look at that, what happened. X is equal plus or minus 2i. So remember my recommendation. When you try to find something in algebra, and you get the imaginary number or complex, it's because do not exist. So the restriction that you try to find do not exist. Do not exist. But there are more. There are more. That is a reason, when it's imaginary or complex, that is a reason that in the real field, we cannot do the factorization of this. No, impossible. Impossible. Okay? Okay? So what is the answer, guys? What do you suppose is the answer? So what is the domain? What is the domain? See, I try to find restriction and do not exist. In other words, we have no restriction. What is the domain of this rational function? The domain is all real number. Remember the supposition. This is important concept in college algebra, guys. Any function that you face, you suppose in principle that the domain is all real number. You find restrictions. The restriction you consider as the bad guy in the domain because to be undefined, my function. See, I try to find, and I get que es imaginary or complex because do not exist in the real field any restriction. Therefore, its domain is all real number. You write in English like that or in interval notation like that. Any question? Any question? A number 3 example.
I have a question.
Go ahead.
Can you explain a little bit more about how to find the domain and the restrictions? Because the last time you explained that, I didn't really understand it that much.
Yes, look at that. What does the agreement for finding the domain for any function? Find the domain for the any function. One function is given. The agreement is you you assume que es Orion. Except restriction. And the restriction we have in several situations. We have restriction when you, for example, our function is division. Suppose restriction number 1 is P divided by Q. You suppose que Q no 0, que is our case. We have another, but it's not important, totally irrelevant, but it's okay when you have a radical, non-negative. I suppose you remember this story, yes or no? You never see before this?
Yes.
Okay. Okay, you forgot that part because my function that we study now have no or do not contain radical. So I focus in this kind of restriction. Okay, then I take the polynomial and the denominator. Okay, you enforce it, no 0 is illegal to be 0, but I feel more comfortable solving the equation of inequality. Entonces, this is the thing I did before, que the answer is plus or minus 2i. Do you? Yes or no? Wait, yes. I don't finish. Yes. Now, interpretation this. Well, the restriction living in another dimension, not in the real field. Therefore, the conclusion is the domain of this function is all real number. Super clear or super confusing? Come on.
I'm a little bit, so the whole point is just that it can equal 0, so how do you...
A little bit what?
Huh?
Go ahead. And listen.
The point is that it can equal 0, but how do you find like the restriction? Like what type of math do you have to do to be able to find that?
Okay. The only thing I did was solving this quadratic equation. Okay, the super easy way for solving this quadratic equation is use isolate the x squared and move forward to the right hand side, apply square root using the square root method, exactly the same we studied in the first test. And you can see, wow, square root negative number is imaginary, so plus or minus 2i. This is the restriction. The restriction living in the another dimension, que es in the imaginary dimension, not in the real field, que es the assumption que we suppose. Therefore, the conclusion means we have no restrictions. Therefore, the domain is all real number. Clear?
Yes.
Good, very good. This is important, you ask me, because you clarify and the rest of the students clarify this. Okay, let's move on to the example 4, que is very interesting and complicated. Look, suppose now okay, we have this function. Let me call m is equal x squared minus 6x plus 8 divided by x squared plus x minus 6. Okay, in the top we have degree 2. And the bottom we have degree 2 also. Nice. Okay, now before to find the domain, I try to manipulate in order to express it in factory form. In factory form, so our mx. Okay, I try factorization, the polynomial, the trinomial, sorry, in the top. Okay, the combination, I suppose, que 4 and 2, no? 4 and 2. Because 4 times 2 is 8. Somehow 4 plus 2 is 6, both negative. And the polynomial at the bottom is 3 and 2. 3 and 2 because 3 times 2 is 6. And 3 minus 2 is 1. In this case, no same sign, is completely opposite sign. This is a positive and this is a negative. And you can see that the factor x minus 2 we can delete. We can cancel out. And stay mx is equal to x minus 4 divided by x plus 3. And now the interpretation. Interpretation. Pay attention because this is a little bit complicated. So our original rational function, okay, is equivalent to this except n2, que es the factor que es gone. The factor que is gone when you doing the cancel out, the simplification. This is a whole. It's called the whole. And when you are doing the graph of this curve, in 2 we have a whole, like that, a whole. However, the binomial or the polynomial in general que stay alive in the bottom is the asymptote. Okay, I want to explain in detail now what is that. It's the asymptote. Okay. So we have two different behavior, whole and asymptote. Okay, pero conclusion, what is the domain? Well, the domain of the original function is all real number such that we have two restrictions. The restrictions are the zero of the polynomial in the bottom of the original, que es no 2, because in 2 we have a whole, I discovered that, and a negative 3, and negative 3. And negative 3 is also undefined, but another way to undefined because it's the asymptote. Okay, I want to explain in few minutes, so you have no question. Okay, guys, so now, what's the conclusion? The conclusion is, immediately you face one problem of the rational function, you factorization, top and bottom. The factor gets cancelled, can not always happen, but sometimes happen. This is considered the whole in the graph. And the graph, the factor that stay in the denominator is the asymptote. In this case, we have two asymptotes. Look, in this example, we have two asymptotes. I don't say that because this is not the moment to talking about asymptote, but we have two asymptotes here. We have one asymptote here. We have no asymptote. No, because it's complex. In this case, we have 1, 2, 2 undefined, 2 undefined, 2 and negative 3, but 2 as a whole and negative 3 is the asymptote. Okay, maybe you don't see very clear now, but I promise in your moment we need to continue advance to see what is the idea for the asymptote. This is extremely important. Okay, I understand. Okay, you are not 100% clear. You are partially clear, right? But you get the main idea or no?
Yes, but I have some questions.
Okay, go ahead.
On question number 4, why do you factor instead doing a quadratic equation?
Well, okay. When you find the quadratic equation, you can do in both ways. Pero, no, of course. But what is the best way, in my opinion? No? When you solving the quadratic equation, the thing we are finding is directly the zero. No, it's not break it down the trinomial into factor. That's the thing we want now. Okay. Entonces,
Yeah.
you can. In principle, yes, it's possible. And maybe, but I do not recommend. I try by factorization, guy.
Like,
I don't.
another question.
Uh-huh.
When you factor and you delete the x minus 2 on the top at the bottom,
Absolutely.
you say that the whole is 2, but I see in the equation that is minus 2, and the asymptote is plus 3, but you put it like minus 3. Why did you change the sign?
Good question. Because the factor actually R means x plus 3 equal to 0, and x minus 2 equal to 0.
Okay.
Got it?
Yes.
Excellent.
Thank you.
Okay, guys. So let's go directly to study in detail now the asymptote. We have different kind of asymptote in our function. Okay, the first one that we study is called a vertical asymptote. Vertical asymptote. Okay. Let me see definition first. Vertical asymptote definition. Vertical asymptote definition is okay. Let me try to understand graphically. We have different kind of asymptote, 4 kind actually. Okay. Suppose one point here, C. I call C. C maybe a number, 2, 3, 4, 5. Entonces, the idea, the definition is when the X approaches to C. Approaching means, let me try to explain what is the idea for the approach. Approach is not equal. Approach is, suppose que X approaches to 2. What means that? Que you go close to 2. And you can go in 2 directions. For example, 2 plus and 2 minus. Okay, this is no negative 2. This is 2 minus. That means that X approaches to 2, but to the number bigger than 2. So maybe 2.1, 2.05. Okay, it's to the right. To the right. And 2 minus is approaching to 2, but to the left, 1.